Hi everybody, welcome back. This is the last video in the part 1 section of the June 2024 Regents exam for Algebra 1 in New York State. We are working on questions 20 through 24 in this video, and if you need any of the other questions previous to 20, there are a few other videos available for you as well. Okay, question number 20. The functions f of x and g of x are graphed on a set of axes below. Okay, graphed on a set of axes below. What is the solution to the equation f of x equals g of x? Now, the solution in this case are the points where the parabola and the line intersect. So we have a point here and we have a point here. Okay, those are our solutions. Straight up. No issues, right? That point and this point. So what are the coordinates of these 2 points? Okay, this is 1, comma, -1, -2, -3. And this is 1, 2, 3, 4, 5, comma, 1, 2, 3, 4, 5. So that's the point 5, 5. Okay, so now, usually by the time you get to the end of the exam, the end of the part 1, the questions get a little trickier. This one looks pretty straightforward. Okay, the answers are 5, 5 and 1, -3. And we look at our choices and those points are not there. Okay, what the question is asking you to do is recognize that we don't want the points where they intersect. We only want the x values where they intersect. So we only need the x values. Okay, so the x values, okay, are 1 and 5, 1 and 5. Okay, so it's still not the most difficult question at the end of the exam, but you do have to recognize that that's what they're looking for. Okay, and look at the other choices. -3 and 5, that would be your y values. Okay, assuming they're looking for y. 0 and 4. Okay, 0 and 4 is, those are the roots. Okay, 0 and 4 would be the roots, which is another term for solution if you're looking just at the quadratic. What is another choice? -5 and 0. Okay, -5 and 0. I don't even see that. And like, I don't even know why that would make sense. Okay, but that's our answer. Let's move along. When babysitting, Nicole charges an hourly rate and an additional charge for gas. She uses the function C of H is equal to 6H plus 5 to determine how much to charge for babysitting, the constant term of this function. So there's 2 things that we need to know for this question. Number 1 is, what are the parts of this function? And this question comes up, or this type of question comes up very frequently. So if you don't know the parts of your function, I would suggest you write them down in the back of your review book, in a notebook, on an index card, somewhere where you're keeping track of all the things that you know you're going to need to study, right? We've been doing box plots. We've been talking about vocabulary in this exam, lots of different things to make your mind swirl. So make sure that you know the different parts of an equation. Okay, so the C of x is like my y equals, and this is going to be the total of your final problem. When we're doing these problems, right, kids ask, why do we need to know this? Okay, these model real life types of situations. Okay, you have a total. You begin somewhere, you change it, and you have a total. So with that being said, this is your mx plus b. This is where your problem is going to begin. Okay, usually with some kind of a phi, okay, on these real world issue problems. Okay, the x is your h, and h stands for hours. Okay, but whatever it happens to be, this is always going to be your time. Time is x, x is time. Right, and then the other one is going to be your m, and m is your rate, your average rate of change. Okay, and we just did a question in the last video on average rate of change, right? Your slope, how much does it change? So we begin, we change over time, and we end with a total. Okay, this should be in your study guide, knowing these parts. This question shows up every single time. Next thing, constant. What is a constant? Okay, a constant is a number that does not change. Okay, so you need to know that vocabulary word. A constant is a term that does not change. And if I look at what we have here, we have a total. Okay, your total changes, right, from the beginning of the problem to the end of the problem. Your rate tells us how much we change by, and it depends on how many hours the problem takes to happen. Okay, in this case, babysitting. The fee, the beginning, is your constant. Okay, it doesn't change. Every time she goes babysitting, she's charging a fee of $5 for gas. Okay, so that doesn't change. You want her to babysit? She's charging you $5 to show up. Okay, so total, rate, hours, fee, beginning, constant. Okay, good stuff right there. Write that down. All right, so what's the constant? We know the constant is 5. The additional charge for gas, the hourly rate, the number of hours, the total. Well, based on this, the only answer that could possibly work is the additional charge for gas. Okay, number 22. When solved for x, we're solving for x in terms of a. Okay, that means it's going to say x equals, and the a's are going to be over here. Let's solve. Okay, 3x minus 7 is equal to ax plus 5. I'm writing it down in my workspace. Okay, so for those of you who think you don't need to do any work for the multiple choice, okay, in most of these problems, you're a little mistaken. Just because you know how to do something, sometimes the work helps you clarify and helps you find mistakes. So if you're not doing the work in these problems, you might be losing out on some very valuable points. Alrighty, so the question always comes up, do I have to show the work on the regions on the multiple choice? On the regions? I'm breathing, okay? You should be doing the work, okay? Never mind about what you have to show. And that's all I'm going to say about that. Okay, so we're solving for x. I have my line down the middle. I have an x over here, I have an x over here, and to solve an equation that I don't know how to start, I'm going to go to PEMDAS, and I'm going to work PEMDAS in reverse. So I'm going to do the addition subtraction step first. In this case, I'm going to do addition subtraction with my x's first in order to keep them positive. So I don't know what a is, but I don't want my 3 to be negative, so I'm going to minus ax from both sides. Okay, 3x minus ax is 3x minus, what did I write, 7? 3x minus ax. We can't combine them because we don't know what a is, we don't know what x is, so it's just 3x minus ax. Okay, minus the 7 equals cancels. This is called the additive inverse or the additive property of equality. We're adding to make something go away and stay equal. And then this is equal to 5. Okay, I'm going to do the addition subtraction step again. Plus 7, and I get 3ax. 3x minus ax cancels, additive property of equality. 5 plus 7 is 12. Now, I know I have a 12, right? And I know that it's probably going to be on the numerator. So if I look at my choices, because I know I'm going to divide here, it's probably going to be this one or this one, probably not this one, and probably not this one, okay, unless something weird happens in the problem. Okay, I'm still solving for x, and I have an x in both of these terms, so I'm going to divide the x out. This is called factoring out a GCF, a greatest common factor. And if I divide out the x, I'm left with 3. And if I divide out the x, I'm left with minus a, and that's equal to 12. And I'm running out of space. Okay, so to solve for x, okay, I'm going to do this division term. I'm going to divide by these parentheses, 3 minus a, and divide by those parentheses, 3 minus a. Okay, the 3 minus a will cancel, and I'm left with x equals 12 divided by 3 minus a. Let's go to our choices. I was right. The 12s don't go on the bottom. 12 divided by 3 minus a. The only thing's missing is the parentheses. So this is choice 2. Okay. Okay, number 23. Okay, these questions have been coming up more and more frequently. Okay, Wade van Niekerk, a runner from South Africa, ran 400 meters in 43.03 seconds, 43 seconds and 3/100 of a second, to set a world record. Which calculation could determine his average speed in miles per hour? This is the nicer of the problems because they're actually given the unit that you want to end in. You want miles on the top and hours on the bottom. Okay, but I'm going to go over the problem as if we did not have this, because sometimes they ask you which one is correct. Now, this is a simple question where all you need to do is know how to reduce a fraction. So let me give you an example. If you have a number like 5 and you divide by 5, they will cancel, leaving you with 1. So if I have units such as miles and I divide by miles, they will cancel, leaving you with 1. Okay, that's the concept we're looking for as we do this question. So in summary, this is good. Okay, if my miles are next to my miles, I can't cancel, and this is bad. Okay, so let's use that with all of our units. So meters, meters next to each other, not good. Don't choose choice 1. Meters, meters, those cancel. So far, so good. Seconds, seconds next to each other, even though there's a meter in between, they're on the same level. Okay, so this is not good. Don't pick choice 2. Okay, meters, meters, seconds, seconds, miles per hour. Looks like what we want. Okay, but so that looks good. I'm going to check choice 4. Meters, meters on the same level, not good. Okay, don't pick choice 4. So your answer is choice 3 by simply eliminating and canceling units by units by units. Okay, number 24. Usually the hardest question of the entire exam. Okay, which function has a domain of all real numbers and a range greater than or equal to 3? Okay, 2 things you need to know. Domain, which are your x values, okay, and your range, which are your y values. Okay, all real numbers is a vocabulary you need to know. So those are all the real numbers, which means that your domain is going from negative infinity to positive infinity. That's what that means. Your domain goes from this. So let's just review that one more time. If I have a graph, okay, and we have all different kinds of graphs here, right? We have 4 different kinds. I have a graph. My domain is going to look like this. Okay. How do I measure from the left to the right? Okay. Whatever this number is to whatever this number is, that's going to be your domain. And in this case, they want it to go from negative infinity to positive infinity, which is what happens in a lot of our graphs. Your range is going to be measured or sought out by looking from the top to the bottom, or more specifically from the bottom to the top. So some of these graphs have a bottom, okay, namely the quadratic has a bottom, okay, and your absolute value has a bottom. So these 2 graphs are going to have ranges, okay, the other 2 probably not. So the best thing that you can do on this question is put each choice in your calculator and analyze what's going on, okay, one graph at a time. So my first graph is a linear function, negative x plus 3. When I graph it, okay, it keeps going and going and going and going. So yes, my domain goes from negative infinity to positive infinity, and so does my range. My range is also going on forever and ever in both directions. So my range is not going to be equal to 3, so this is not correct. Okay, so let me just draw that for you. This is choice 1. This is your linear function. Your domain goes from negative infinity to positive infinity. And your range, your y values, starting down here, right, are going from negative infinity, okay, to positive infinity. Okay, they're going from negative infinity to positive infinity. Okay, number 2. G of x is equal to x squared plus 3. So I'm going to take my function and I'm going to type this in as x squared plus 3. Okay, I'm going to graph. So this is a quadratic. And if I look carefully, I just have to look closer. Okay, 1, 2, 3. Okay, this point is 0, 3. So when I go to my table, okay, what's happening at 0? I just want to check that number. Yep, that is 0, 3. So this is what's going on with number 2. We have a quadratic. Okay, again, your domain from left to right is going from negative infinity to positive infinity, but your range is going from this number, which we found out to be 3, up forever to positive infinity. Okay, so that has a range of 3. Okay, that looks like it might be a contender. So all of these points are greater than 3. So this looks like it might be a good answer. Okay, number 3 is the exponential function. Y equals 3 to the x, 3 up arrow x, graph. Okay, that's an exponential function. It's looking like this. Okay, again, your domain is going from, because it keeps on going and there is no bottom, from negative infinity to positive infinity, and your range at the bottom, it's not going to negative infinity. Look what it's doing. It's going to go along and not cross 0. So it's going greater than 0, not equal to 0. So your range, your y values are greater than 0. So it's still not this one. Okay. And then choice 4. Let's see what happens. Okay, this is an absolute value. To do an absolute value, you're going to go to math, okay, over to number, and then down to number 1. Okay, there's your bars. Okay, I'll write that down for you in a second. Actually, I'll write it for you now. That's math, NUM, and then option 1, math number 1. Put that in your study guide. Okay, and in the bars, we're going to type x plus 3. Okay, step out of the bars and graph. Now that 3 would be kind of cool, right? But it's not going up 3. It's going 1, 2, 3 to the left. Okay, so this one goes like this. Okay, so it has a domain that keeps on going from negative infinity to positive infinity, but your range goes from 0 to positive infinity. Whoop. So your answer is choice 2, because it meets both parameters of the question. Okay, a little bit tricky, okay, but you got to know domain and range, or at least have a pretty good understanding of it. And that's the end of this video. Thanks for joining me. Bye-bye.